Hi everyone. Today we will explore a statistical claim about the average height of men born in China, which is said to be 171.8 centimeters. Our objective is to test this claim using a statistical hypothesis test at a 5% significance level. Through this process, we aim to determine whether the data supports or challenges the claim. To begin, we have to establish our hypothesis. The null hypothesis assumes that the average height of men in China is 171.8 centimeter, and the alternative hypothesis suggests that the average height is different from that. And the reason why setting up the alternative hypothesis is that the most of Chinese I saw are taller than the average height. Hence, I'm keen and curious to know whether the data I collected can substantiate the data or not. I selected the 30 sample data randomly for the height of men born in China from a website. Collecting sample data randomly reduces bias and ensures a more accurate representation of the population. Certainly, to do the two-tailed test, we are supposed to find some basic values, as shown in part 4. The sample size is just the amount of data I collected, which is 30. To calculate the sample mean, we can use the powerful Excel to get the value. Based on this formula, we just simply type the capital letter average and select the 30 data value, then we can get the answer. Similar to the sample standard deviation, we type stdev.s and also select the 30 data values to get the standard deviation. And the population mean is given as 171.8 in our claim, and the significance level is 95%, which is 0.05. With these values, we conduct a t-test to determine if the sample mean significantly deviates from the claimed population mean. So to do the t-test, we use the sample mean minus the population mean and divide by the sample standard deviation over the square root of sample size. To find the p-value, we use the formula to calculate it. We type t.dist.rt, and inside the bracket, we type the absolute value of t-test, comma sample size minus 1. And the reason why I use a t-test instead of a z-test is because the website does not provide a population standard deviation, and we are unable to perform a z-test without this value. The significance level is a preset probability value in a hypothesis test. The 5% significance level indicates that there is a 5% probability that the null hypothesis is actually true, but we reject it incorrectly. The p-value is a probability that the observed sample is at least the same as the actual observed sample. If the null hypothesis is true in the hypothesis test, a small p-value means that the probability of observation under the null hypothesis is small. So, if p-value is less than or equal to our population mean, we reject the null hypothesis. On the other hand, we cannot reject the null hypothesis. From the observation, the p-value is less than the significance level. So we can conclude that there is sufficient evidence to reject the claim that the average height of men born in China is 171.8 centimeters. The margin of error refers to the amount of uncertainty or variability in this estimate. We use this code to calculate that. And finally, the 95% confidence interval for the population mean is here. We use the sample mean to add and minus the margin of error to get the range. That's all for my math assignment presentation. Thank you.